right, thank you so much. This is going to be an English talk, so I attended some of the talks and they were in German. I'm sorry, I don't speak German. The only word I speak in German is danke. So danke for being here and danke for having me. So my topic is property-based testing and property-based testing for preserving invariants. That's a big title, but I'll get into that. But just a quick intro about me. So namaste. I'm from India. I have been a software engineer for 10 years now. And for the last 5, I started exploring the craft of software engineering. And I do that by writing, speaking at conferences like this. And if you search for my name, you might find a few articles out there. And as of today, I'm working at Booking.com in Amsterdam, where I'm living for the last 2 years with my wife. We moved here from India around January 2023. And that's where I'm coming from this morning as well. And that's where my story starts also. So just after a few months after moving to the Netherlands, we decided to take our first trip to London. We were quite excited. It was our first trip since we left our home in India all the way to Amsterdam and Amsterdam to London. Unfortunately, a few hours after reaching London, my wife's purse got stolen, and with it, her phone, her residence permit, which you need to enter the EU. We were completely stranded. We were not EU citizens. We feared that we would have to return back to India. So we were quite lost at that point. And we were looking for any hope that would save us from this really tragic set of circumstances. And that's when I still had my phone. I got a message from Apple saying, hey, you know what? Your phone has been found. So we were overjoyed at that point. More happy to find that my phone has been found than I was to reach London in the first place. And I click on it, takes me to iCloud, no surprises there. But unfortunately, this is not really Apple. This is the person who stole my wife's phone. It is not even Apple. It's looking like apple.uk, but it is actually spelled as appy if you look at the URL. So I was almost going to enter my iCloud credentials there, but I did not because I was next to an Apple store. And they categorically told us that Apple would never do such a thing. Apple would never send me a message saying that you have to sign into a site. That would never happen. And that is the invariant that saved us that day. Because although we lost everything almost our way back home, it could have been much worse if I had just fallen for this. So this is an invariant. An invariant is a property that remains unchanged in a system no matter what happens. So transformations, operations, processes, whatever happens in your system, invariants are the things that do not change. And in this case, it was this declaration that Apple would never send us a link to sign in. So invariants are very important in life, but also important in systems. And in this talk, I'll be focusing on invariants in systems. And that is important because we live in a world of change. Whoops. Let me try. Yeah, OK. Yeah, so we live in a world of change. Software engineering is to deal with change. So requirements change. We need to build more things into our applications. People who build the system changes. The tech stack we build on changes from time to time. Infrastructure changes. And even the usage patterns that the people who use our applications and the systems that we build changes. But the one thing that doesn't change is the expectation that users have from our application. So they keep coming back to our app or system because they rely on us, they trust us to give them what they are looking for, and that doesn't change. And that trust, we cannot violate that, no matter how many changes we are doing it, right? So we are making changes constantly, but we cannot break the expectation from the user. So this is invariant. Invariant is that unchanging property that, irrespective of any user action, any system state, or any code change, does not change, right? So what does it look like? So let's say we are building an API endpoint. We want to make sure that we don't send stack trace in the response, like a null pointer exception, for example. That's never good. We never want to do that. If we are building a banking application, it would be something like, if you're doing an interbank account transfer inside the bank, the amount of money doesn't change. If you're meeting an application that is about meetings, you can one person cannot be in 2 meetings at the same time. That's the invariant of that system. And if you are building a sorting algorithm, it's to make sure that after the sorting algorithm, every element is less than or equal to the next, right? And so on. So these are the unchanging properties of systems that we build. These cannot change, no matter what else changes. And that's where property-based testing comes in. Because it starts with a property, also known as our invariant, And it tries to take as many random inputs it can think of, and tries to find the smallest input for which this property doesn't hold. And if it is not able to find any input for which the invariant doesn't hold, then that means that there's no bug, the invariant is actually unchanging, right? So let's take an example. Suppose we have an application that relies on the number of days in February. So if that was the case, I would write a test like this. Say a test that validates that 2015 has 28 days in April, 2020 has 29 days, and 2021 has 28 days. This is a good enough test that I would write. I would be happy with it if it works. I would ship it to production, right? There's nothing wrong with this test. I like it. I would have written this myself. Let's look at a property-based test that would do the same thing. So first of all, in a normal test, or an example-based test, as I call it, we are giving it examples to test it. So these 3 years, 2015, 2020, 2021, and no matter how many times we run this test, it is only going to test these 3 cases. In a property-based test, the fundamental difference is it doesn't take the years as input, it takes a range. That is the sphere of the problem space. And here we are saying, okay, I care about all the years since 1800, and go check if the leap year logic that I have works. And it doesn't. So when it doesn't, it gives me an output. I'm using the jQuick library, which is a library that implements property-based tests in Java. It says that, in the first line, it says that, hey, I tried 51 inputs, so 51 years, so not 3, 51 that it generated itself, and I found 1 failure. What is the failure? The failure says that for the year 1900, the logic that I have for checking leap year doesn't work. And it doesn't work because 1900, although divisible by 4, is not a leap year, because for a year that is divisible by 100, also has to be divisible by 400, which it is not. And this is a bug that I did not think of, my example-based test did not think of, but the property-based test kind of found, right? So these kind of sample tests, like examples that we think of, are prone to false positives. It's like looking at one Lego brick when you're sitting around a sea of Lego bricks, and you're looking at this one Lego brick very, very intently, but ignoring the rest. So these kind of sample test cases give rise to what I'm calling accidental quality. So you start with testing the base cases, like the simple cases. For me, it was the 3 years. But as the system grows and becomes more complex, we are not going to be able to test everything because we don't have the time to write down everything. Enumerating all the examples is not possible. So soon enough, we handpick a few examples, we test it. Those work, that's for sure. But every now and then, we might leave a bug in the code because we just didn't test it. And soon enough, if this grows, the experience that the user gets is that, oh, if I do this, there's a bug. Oh, if I do that, there's a bug. But our builds are passing, right? So in my mind, if I have a system like this, when would I write a test case for this? I would write a test case only if I think, by some intuition, that there might be a bug there. But if I don't think of that case, I would just let it go to production, right? And therein lies the fallacy of picking and choosing examples, right? Now, taking a step back and looking at how property-based tests would look at this thing, instead of us having to handpick examples, it will try to search the problem space. It will start exploring whatever is possible by generating random inputs, kind of like walking a graph. And if it does find a problem, it doesn't rely on my knowledge of that bug. It can be something that I completely don't understand. It will find that bug without my knowledge, right? So that's already a good thing. But it doesn't stop there. That's the beauty of it. Once it finds a bug, it tries to reduce the space that causes this bug and find the minimally occurring input for which this bug happens. And that's very useful for the iterative feedback to me as a developer to go and fix the problem, because just knowing that there is a bug is not going to help anyone if I ship it, right? I'm going to have to solve it. And to solve it, I need the minimal set that causes this failure. So let's take another example to illustrate this, right? So I have a sorting algorithm here. In my normal test, I would write, take a list and sort it, and see that the sorted list is sorted. It passes, it's all good. A property-based test, on the other hand, would take the entire space of problems. So for this, it would be every list of every possible integer. And the system now will try to generate this input. And for every input, it will try to say that, hey, if I have a list, if I sort it, every element in that sorted list should be less than or equal to the next. And when I run this, it fails. Why does it fail? It fails because it ran into a case of this 20-element array for which the sort logic doesn't work. But that doesn't help me much. It found a case, that's good, but where do I go from here? I would have to sit down with a pen and paper and try to see where the bug is. That's not feasible. What it does is it tries to minimize the input. Here, takes 11 steps and tries to find the smallest case for which it fails, and it finds a 2-element array. Now, that is something I can work with, right? Every time I run this test, it starts exploring the space, finds some failure. As you see at the bottom, it's a different sized array, but it always shrinks down to the smallest failing case, which is, in this case, a 2-element array. And this happens over and over again. Every time I run it, it encounters a random failure, shrinks it down to a 2-element array. And that helps me find the bug, because in this case, the last number never gets sorted. It's a bug in the code that I knew already. But interesting thing, if it was in 1-element array, the bug doesn't happen. So the shrunk, the smallest case, is only a 2-element array. So now let's put this into a real application, right? I'll be building a meetings application, and I'll be trying to show that invariants play a very important role in finding these bugs that are not super easy to detect. What am I trying to build here? I'm trying to build a calendar application. We have all been there. If there is an existing meeting, we cannot be in 2 meetings at the same time. So we should not allow anyone to create a meeting that overlaps with any meeting that I've confirmed for attending. So all of these meetings, they are overlapping with my existing meeting in yellow. So they should not, they should not be allowed to be created. But these green meetings should be OK to create because they are not overlapping with my existing meeting, and I can go from one to the other. So this is a very simple application. It's not very complex. It allows me to create meetings, invite others to meetings, accept or reject invitations. And as such, there are a few endpoints, 5 endpoints, one to create the user, one to create the meeting, and then accept and reject invitations. So let's try creating a meeting. I go to the Swagger UI, I enter, let's say, Alice's first meeting in Calcutta, that's my hometown. And the moment I do that, I run into a null pointer exception. And this is a Swagger UI, but think of it being out there, being the reputation of your company or the project that you're building, and the user gets a null pointer exception, Spring something, servlet something, internal something. The user wouldn't know what to do here, right? And we cannot allow this to happen because our application should protect against these kind of leakage of failures. And this is a very simple application where this happens. The simple application which has already so many fault lines, but this is not just my system. I'm not writing a really deliberately buggy system. This was found and presented in OSDI 2014, which is a very prestigious conference, that simple testing can prevent very critical bugs. So the authors looked at systems like Cassandra, HBase, MapReduce, Redis, and they found that many of the bugs that were shipped to production could actually have been prevented by a unit test, right? But the question in my mind is, why didn't it? How do we know that we have written enough unit tests? There is no yardstick to measure that we have enough unit tests so that there is no bug. So that's one question. Second finding from this paper is that some failures require more than one input event, which means more than one interaction from the user. And because there is more than one interaction from the user, the number of possibilities is quite large. So A happens, then B happens, and then C happens, and then the bug happens. I don't think it would be possible to enumerate all of these sequences in a test case. So this becomes a combinatorial search problem that just manually seems hard to do. So what do we do here, right? So let's try to use property-based testing in our application, the meetings application, and let's go on a hunt or a search for these kind of lurking bugs. So in the presentation layer, we want to make sure that we never return any data to the user that they don't expect. So no null pointer exceptions, no stack traces. In the business logic, we do not want to ever break product rules. In this case, it will be the overlapping of meetings. So nothing ever should allow me to create overlapping meetings. And in the database interaction layer, we want to make sure that all the queries that we write are going to work for all kinds of possible data combinations in the database, right? Imagine that the database has been there for 5 years. Different types of data is there in the database. We want to make sure that it works for all of them. So I'll be doing a demo here. The code that I'll show is on my GitHub profile, github.com/mourjo/quick-meetings. So you can check it out. But right now, this is a Spring application. Is that visible at the back? The code. You don't have to read everything. I'll explain. But let me just show you that this thing actually runs. And I'm not deliberately showing a buggy application, right? So this is a Spring application. It started. If I go online, there is a Swagger app. Let me create a user. So let's say I'll create my username. And you see that I get a 200. I get a JSON response. The ID is generated. So it's working that way. Let me create a meeting. So my user ID is this. So techCamp Hamburg, say from 1400 to 1445 in Europe, Berlin. All right, so it makes the request. I get a JSON response. 200, could have been 201, but it generally works, right? There's no like obvious bug here. So let me kill this app, and let me just start testing the presentation layer with a property-based test. So in the first test, let's make sure that the user never gets what they do not expect. And in this case, we do not expect the user to get anything other than JSON and never a 500, let's say. So yeah, it fails. And it fails because I expected a JSON, but I'm getting an HTML. That is not what I saw in the demo. You see that I'm getting a JSON, of course, when I try it out manually. But somewhere, the application is returning an HTML. So let's try to dig deeper into it. OK, so here, the system is generating all kinds of inputs. It is going to be random. It is going to be what the user could send. It may not be something that we expect, but it is not illegal. For example, there's a delete. This test is generating an input for the delete endpoint to the path, to the root path. But I don't have that in my application, right? I just have post user, post meeting, and reject, accept meetings. But it is not illegal for the user to call this, because you can call an endpoint. And my application, in its infinite wisdom, is returning HTML. Why is that happening? If I dig a little deeper, it is because of this. The user is sending a text HTML as the accept header. But in Spring, if we write an endpoint in a controller, it will always return the data that we are generating. So it's not going to fall back to anything like HTML, because it doesn't know how to do that. But it will happen if it is an endpoint that doesn't exist, that we did not write, and there is an accept header that is HTML. So that's exactly what is happening here. In this test, if I go into the test, what we are saying is, hey, you know what? As if it is an API, the user can call whatever they want. So go and find a request with whatever method you can generate. So this would be get, post, put, and delete as well. All kinds of paths, all kinds of content type header, all kinds of accept header, and all kinds of body, and expect that the JSON data will be returned, no matter what the input is, right? And expect that it is less than 500. And that doesn't work. So I have a fix for this. So the fix is not important. The finding of the bug is, because if I was testing this application, I wouldn't go and test an endpoint that doesn't exist, right? But the fact is that I have this helper that is going to do it for me, so that in the event that the user does this, they don't run into this kind of issues. And the fix is quite simple. I tell Spring not to use the header that is coming in the request, but always to use JSON. So if I now run the test, it should work, right? Because we told Spring explicitly never to return non-JSON data. Oh, but it fails again. Let's see what happens this time. OK, in this failure, again, it is trying to generate different kinds of input. But this time it fails with a 500. At least it's not HTML, right? That's already some progress there. But it's 500. And it says it's internal server error. Although it's JSON, it's not very helpful. We should not let this happen, at least not in a test. If our database went down, this is OK. But in a test, just because the user sent certain requests, we don't expect a 500. So here, the endpoint looks good. It is a valid endpoint, post-meeting, so it's not a non-existing endpoint. accept header looks good. It is JSON. It's again generating all of this. Body looks like it's JSON, so OK, it's fine. So let's see what might have gone wrong here. I see a null pointer exception. OK, something from something was null. Let's look at the code. It fails in this line. And it looks like we expected the request to have a from, a duration and a from, but the duration was probably null, and that's why it didn't work. So let's just validate that. Yeah, there is a duration here, and there is a from nested inside the duration, and the user probably did not send it. So let us look at the request. Again, this was generated by the system. I didn't hard code this. So here, yeah, indeed, when I'm trying to create a request, it expects a duration. It is not there. And the user is hit with a 500, with no way to know what is actually happening. And this was caught by our test, because we said that we do not want to ever return a 500. So let me fix that also. Again, the fix is not important, but the fix is to add exception handlers in Spring, and to say that if such an exception or any other kind of exception that we know of happens, always return a 400, and construct the response in a way that is JSON and that is explaining to the user what is wrong. Right? So this time, if I run the test, I expect it to pass. So again, it is going to go through all the possible values that it can think of. So let us just quickly look at what is happening. So this is a property-based test. I'm taking as input random parameters and validating random parameters that are getting generated on the fly, and I'm validating that it is JSON and it is never 500. And I think it worked this time. So it tried 1,000 test cases. All random combinations may or may not exist in my code base, may or may not be in English, but it never returns a non-JSON, non-500 response. So that's pretty good. We have given a consistent response to our user. We have tested the failing cases, but let's go, still remaining in the presentation layer, let's try testing a happy path. So if you create a meeting and you pass, let's say, valid end and starting points, we expect a 200 or 2xx response, right? And that's what this test is trying to do. So what it is doing, it's again a property-based test. It's saying that, hey, generate some meeting arguments, which has from date, to date, and a time zone. And for all of those, generate them in a way that that is going to be successful. I'll show that in a bit, but expect that it is successful. So what we do is we mock all the service calls. We are not actually storing anything in the database here, but we expect that the result is that meeting is created for all combinations. But for some reason, this doesn't work.
I got a question.
Yeah.
Is there some academic work on this? Like, because you're generating 1,000 tests here, right?
Yeah.
Yeah. Which I really like the approach, but it's not 1 million or 100 million or 1 billion tests, right? So yeah. What do the academics say about this? This chance of finding a bug that you wouldn't find with a few, with a human making some examples. Like, what's the trade-off? And also, in terms of performance, right? I mean, we have thousands and thousands of unit tests in our application. If we suddenly, make them each 1,000 times bigger, then our DevOps guys are going to say, what the fuck,
Yeah. Yeah, that's a good question. So property-based test sits right in between mathematically proven proofs, right? So there are systems like TLA and TLA Plus that actually prove that there are no bugs. So that's mathematically. But we are not going there. I'm not very well-versed with TLA Plus. But this sits in between handcrafted examples versus a fully proven system. Right? So it tries to explore it as much as you would allow it. So I'm saying that I'm allowing 1,000 cases. You can say that, OK, I don't have that much time, just try 500, or just try 2 and see what happens. Right? You can tune it as much as you want, depending on your budget. But in some cases, even if it is not running on the build, you can turn it off in the build. You can run it maybe on the nightly build or on local. It's important to know that there are some blind spots in your code without having to go the mathematical route.
Right. Yeah, cool.
Yeah, so what is happening in this test is that I expected a success, but I'm not getting a success. And the system tells me why it is not successful, and it says that, hey, I tried to create a meeting from 30th of March, 2:52, and the error I got, what was the error I got? Oh, the error is that the meeting cannot start after its end time, which seems like a valid case. But I was sure that this test was going to test the happy path, right? So here, the original sample was create a meeting on the 30th of March from 2:52 to 3:22, which looks okay because 2:52 is before 3:22. So why did I get that error? The error says that the meeting was from 2:52, but the error says that the meeting was from 3:52. So how did it become 2:52 to 3:52? Did it also become something like that? Is that some garbling issue? Sorry? Yeah, exactly. I'm not from a daylight savings time zone, but it exactly finds this in a 6-month period. So if I show you the code, you will see that out of the 6-month period, it found this one case where half of the meeting is in the meeting starts in a daylight savings gap zone, and the other doesn't. So the starting time becomes after because it kind of moves forward. Yeah, so if I fix this, the fix is not important again, but in Java, by default, this kind of time drift will happen. So in zone datetime, if you construct the datetime object from another local datetime object, it is going to do this drift for you. But you can use the strict constructor to say that I don't want this drift. If you fall in the gap, just give me an error. And as such, the test will now expect either the creation successfully or a gap. So if I run this test now, it will work. Just to show you what the code is doing underneath, let that happen in the background. So here, so I have the property. I'm generating the meeting arguments. So this is the meeting args. So what I'm doing is I'm saying, hey, go ahead, take some random point in time, take a 6-month period, and try to create meetings in that 6-month period of 15 to 30 minutes in duration. And in this 6 months, try to see if it all succeeds. And this time it did, but it found a case that I wouldn't think of. I'm from a non-daylight savings time zone. I grew up there. I would not think of this. So I think that's a very powerful result because it highlights that I, as a programmer, have my blind spots. I didn't know about this. It found it. It's an ally that I want to have. But now let's move on to this was the presentation layer. Let's now move on to the database layer. So I will go to another branch. And in this case, what we are doing is we are looking at the database, and I'm saying that our goal is to not create overlapping meetings. And that is happening through a SQL query because we are saving the meeting somewhere, and we want to make sure that the SQL query is correct. And again, of course, it doesn't work. So let's see what the failure is. The test is trying to say that no overlapping meetings can be created. So the test is generating some random samples. Let me just look at the test first. What does it do? Yeah, so it says that take, for all meeting ranges, just start with one meeting start time, start with its duration, so that's one meeting. Take another meeting start time anywhere in that in this bound, take another duration, and see that they don't overlap. How do I do that? I say that I create the first meeting. Initially, there is no meeting, so it's fine. Before I create the second meeting, I ask the database, hey, is this going to overlap? And check the result from the database, and I compare it manually, programmatically. So there are just 2 meetings. It's easy to compare. I just basically say that there should not be a single second which belongs to both meetings. This is possible because I'm just comparing 2 values, but the test is going to generate all kinds of pairs, which is how I'm going to detect, let's say, logical flaws in my SQL query, because when it goes to production, my database is not going to have 2 meetings. It is going to have a lot more. So what does my test say here? It says that it fails because there is a meeting that starts at 11:07 for 17 minutes. There's another meeting that starts at 11 and its duration of 59 minutes. Now, this doesn't say much, because this is just 4 parameters that I don't know what do I do with the 17, what do I do with the 59, is the 59 the problem, is the 17 the problem? I don't know that. But if I look at the shrunk example, which is after this failure was encountered, it shrunk it down 13 times, and it found a case that I can work with. It says that, hey, if the first meeting starts at 10 past 1 second, and it lasts for 1 minute, and you take another meeting that starts at 10, which is just 1 second before the existing meeting, and that meeting is of 2 minutes, then this failure happens. Now, if I think a little bit about it, it basically tries to say that if there is a meeting and there is another meeting that gets created, which is before the existing meeting starts and after the existing meeting ends, the logic doesn't work. And that's kind of a bug, which I actually did not intend. This was not part of the demo. So if I fix this, again, the fix is not important, but in this query that was originally there, I took care of most of the cases, but I didn't take care of one case. And the one case was this one. So here I have, in my original source code, I had covered all the 4 cases here for existing meetings, but I missed this one. That happens only if the new meeting completely overlaps the existing meeting. So in this case as well, the test was able to find this. I did not expect it. I thought my code was fine. So in my unit tests, I didn't test this either because I didn't think of this case. So my unit test did not have it. My manual test did not have it because I'm the author of it. I have my blind spots, but the property test found it. So now that I've fixed it, I expect it to work. And again, how does it work? Just a quick walkthrough. We generate the parameters, and we say that if the database says that it has overlapped, just go check it manually. And this time, it has done that with 1,000 meetings in that given time range. They don't overlap in any of the cases. So 1,000, as you probably already said, 1,000 is a random number, but it's a good enough number, better than 3, 4 at least, right? And I know that it is going to do it without my bias. So that's the main thing. All right, so this was the database. We saw the presentation layer. We saw the database layer. But let's kick it up a notch and go to the business logic. And in this case, I'm going to take a different approach. And what I'm going to do here is I'm going to model users interacting with the system in different ways. So we have multiple users. We have multiple meetings. Let's see if we give it to the world, is it possible that the overlap still happens, knowing that the database query works? So in this test, what I'm trying to do is that no operation from the user should ever create an overlap. No operation that's at the user level, so any of the routes being called. And it doesn't. Now, why would that be, right? So let's start looking at the output. This is looking different from the ones that we saw before. So here, it actually says the user actions. So here is Bob creating a meeting from 10:21 to 10:22. 1 minute meeting, which is OK. Then Alice is invited to that meeting, Bob's meeting. Then Alice herself creates another meeting from 10:21 to 10:22, which overlaps with Bob's meeting. But that's OK, because Alice has not yet confirmed attending Bob's meeting. So up until this point, there is no problem. The problem happens when Alice accepts Bob's meeting. So because now Alice is supposed to be in 2 meetings at the same time, her own meeting and Bob's meeting. So by accepting it, she accidentally landed herself in a situation that should never have happened. And this is not one endpoint that is getting called. This bug would not happen if any one of them was individually called. It would not happen if there was only one user. It only happens when there are 2 users and multiple requests are called. So it's an interleaving user actions for which this bug happens. And it's not very hard to believe that this will happen in the real world. It's just that it's hard for us as programmers to think of this case and encode it. Because if we had to encode this, what else would we have to encode? Would we have to encode everything? Everything is not an answer, right? Interestingly, this one I was able to explain to you, 4 steps, not very difficult, right? But to get to that 4 steps, the system went through a sequence of events that was this long. It explored this many things and then finally found something that doesn't work, and it filtered out the noise to give me something that I can actually work with. And I'm able to explain this to you in like 1 minute. That's really powerful. And if you look at it, this one the first failure that it encountered includes the reject action, but the minimize output doesn't, which means that this reject doesn't play a part in this bug, but the others do. And that's really, really something that blows my mind. So let me fix this. Again, fix is not important, but the fix is that when I was implementing the accept endpoint, I forgot to ask the database that there is that you need to check that there is an overlap or not, right? So once I add that, I do expect it to work. It is there in the creation, but it's not there in the accept. So just let's look at the test for a minute. So this is a property-based test. I'm saying that this time, instead of just taking random inputs, use this thing called the action chain. Action chain is it's kind of an abstraction over the random inputs that we had gotten, provided by the jQuick library. And all that it is doing is that for every initial state, that is an empty database, for example, it says that, OK, you have 4 actions, which is create, invite, accept, and reject. Interleave them in different ways, whatever you can think of. It can be one action, it can be all of those actions, and take multiple users that do those actions. And for each of those combinations, try to see if the overlapping criteria is violated. And once we have fixed that, it runs the test for 1,000 times. But this is not 1,000 inputs. This is 1,000 sequences of user actions that were tested right in front of you, and that prove that all of those sequences, never do we end up with a situation that there are overlapping meetings. That is never violating our product's expectation. 1,000 user actions, 1,000 sets of user actions. To take this a step further, the last demo that I want to show is just building on top of this. So once we have that same action chain, so here what I'm doing is I use the same action chain, but this time I want to validate the opposite of the expectation that we were looking at so far. So initially I was looking at there should not be any overlapping meetings, but let's say, just for the sake of it, we don't want to create empty meetings either. We don't want a meeting in which nobody's there. And if I run this, it'll go through the same process, same combination of interleaving actions, and it finds a bug. And the bug is that if Alice creates a meeting and then Alice rejects it, then the meeting is empty. This is a simpler case, but it builds on the framework of this action chain model of testing. Again, the first failure that the system finds is much more noisy, but it reduces it to a smaller case that I'm able to explain to you. So let's go back to the demo. Yeah, so the demos are online. If you want to check it out, it's available on this repository. So what did we see so far? We saw that there was a bug with 500s. We returned 500s to users just because we did not take care of null pointers. We sometimes return non-JSON responses. We got a bug with daylight savings, which breaks my mind every single time. A SQL bug in detecting overlaps, 1 case out of 4. We saw that accepting a meeting can still create an overlap. Interleaving actions can sometimes behave in weird ways. We modeled that, and the system found some bugs. And we found that rejecting a meeting can create an empty meeting, which is not a good thing. But none of these cases were coded in the test. So I didn't write the examples in my source code. They were found, right? And that's the beauty of it. If I knew all of these bugs, would I write it like that? I wouldn't, right? So it found the blind spots in my mind as the programmer, and it helped me get rid of those. It's not 100% accurate, it's not 100% exhaustive, but it is still better than sampling test cases. So what we are doing when we run tests is that, be it property-based test or non-property-based test, when a build passes, it is an indication that we didn't find a bug, right? It is not an indication that there is no bug, right? It's just saying that in this run, we couldn't find a bug. But property-based tests tries to do a little bit better. It's not 100% accurate, it's not mathematically proven, but it is trying to uniformly search the space that we're in. So it is searching for bugs and not just testing for bugs, which I think is quite useful. So I want to leave you with this question. the tests that you are writing, are they exhaustive enough? Invariants are those unchanging properties of a system that are hard to keep validating by hand, and it requires some manual effort. Property-based tests solves this, or tries to solve this, by exploring the problem space and not relying on enumeration. So if I did not know about daylight savings, I would not write a test for daylight savings. But the property-based test would search for it. And once it finds a bug, it gives me effective feedback by minimally reducing the input to a smallest occurring case so that I can fix it. So it's very effective in giving me feedback. And this defends against accidental quality, right? So by handpicking test cases, what we end up doing is code that works only for those cases that we have tested. So if you have 1,000 users and you're writing 50 test cases, are you sure you're not leaving something? Because if you are, you should try property-based testing. And that's it. Thank you for attending my talk. I'm happy to take questions. The GitHub link is up there if you want to check it out. Yeah, that's it.
Thanks, Mourjo. I do feel motivated. I want to try that out. It was a great talk.
Thank you.
Any questions?
Yeah, thanks again for the inspiring talk. Just one question. Do you have any experience with race conditions and these kind of testing? Because what you show some user interaction variations, very important for sure. What about race conditions?
Yeah, that's a good question. I guess by race conditions, you mean concurrency bugs? Yeah, yeah, that's harder to do with this library particularly. But so property-based testing was originally written in a paper called Quick Check, which was targeting this race condition. And it is there in the Erlang library that tries to do this. But in this one, I don't think it's very easy to model that because it's not repeatable that way, in Java at least. But we can still use it. I just don't think that the results would be that deterministic. So there are other tools that you might use for that. I think for concurrency, a good system to use would be Jepsen. It's a tool for testing concurrency bugs in databases. That might be a very good tool to try out. But I'm not sure if this would be the best case for that. Any other questions?
Then one from me.
Yeah.
How do you ensure reproducibility from CI, where usually overnight my tests run, and my local dev machine where I have to fix it?
Yep. So there are two ways to do it. One is that when the test fails, you get an output for the input that actually caused the test to fail. So in my example, each of those is just a function. So here I'm giving an input. This one is a bit harder to do that way, but for any other example, if it has an input, you can pass that input to the function. But crucially enough, after the build passes, there is going to be a file that gets generated that contains the seed that started the random generation. So if you take that file from the CI and you put it in your local system, it will just reproduce the failure using that same seed. So it will just start with that point. So there's a file that you can use to share the failing case.
Yeah, thank you.
All right.
All right, thank you so much. Actually, we switched because I'm not the technical one here. So thank you, Mourjo. And we have a break, 15 minutes until 3 o'clock. And then we go on with the next speaker. Thank you.